Good morning and welcome to Thursday, May the 7th. This is AP Statistics. Today we're going to answer questions 5 and 6 from the 2018 FRQ section. The first one gave you a graph, two graphs really. A and B, they talked about teachers in districts and the years of experience that they had. So the two histograms, clearly not normally distributed, showed you, let's see, in A, we had 200. So in District A, our sample size was 200 teachers, and the mean was 8.2. Now, they didn't actually give us a standard deviation, but I'm just going to put that there as a placeholder. District B, 221 teachers, also an 8.2 mean. Question is, in Part A, one of the distributions has a median of 7, and one of them has a median of 6. Which one's which? There's two ways you can go about answering this. I'll give you both. First, I'd say this. It's pretty evident that distribution B has a much stronger right skew than A. A also has some right skew, but nowhere near as strong as B. So far, so good. When the skew is so great, what happens to the mean? The mean gets pulled towards the skew. So the mean is going to be pulled higher above the median in distribution B than it will in distribution A. So if the mean is pulled higher above the median, that kind of tells us something about the median for distribution B. I'd say distribution B has the median of 6. But if you don't want to go that route, there's always counting. Distribution A has 100 teachers in it, and we're asked to find the median. It's just counting. So if you count in distribution A, the 100th value, there were 200 teachers in A, the 100th value is in the 7 to 10 class, obviously, making its median 7. And in distribution B, which had 221 teachers, the 110th value, or the 111th value, if you just count, is in the 4 to 7 class, because it goes up to 113. So you could pretty clearly say that the median is 7 in group A and 6 in group B. In either of those two methods, either counting to see where the middle value falls in which class, or using the context of the skewness, both will give you the answer. Okay. B, part B, tells you that we accidentally omitted 18 teachers from distribution A whose average teaching experience was 2.5 years. So what's the new mean? Well, it was 200 teachers times 8.2. We're just unfolding. 8.2 was the former mean, so now I have all their years. And now the 18 teachers with average experience of 2.5 years divided by the new 218 teachers, total 7.7294 years of teaching experience. All right, so we're just unfolding and recreating a new mean. 200 times 8.2 plus 18 times 2.5 divided by the 218 teachers in district. That's part B. Part C. It wants to know the probability of finding someone at random from distribution B who has within one standard deviation of the mean. So are you going to use normal CDF from, let's say, -1 to +1 with 0 and 1 as the mean and deviation? No. Why not? It's not normal. It's anything but normal. Distribution B is very skewed. Are we doing a sampling distribution of the sample mean so we can normalize the curve? No. We're not doing random sampling of a group of size n. This is talking about a teacher. You can't use normal probability on a very abnormal and not normalized distribution. So what can we do? Well, if 8.2 was the mean, and we're being given a deviation now for distribution B of 7.2. So we just never know or care about A, but 7.2 is the standard deviation of the curve here. So what would mu minus sigma be? 8.2 minus 7.2 is 1. What would mu plus sigma be? 8.2 plus 7.2 is 15.4. I'm looking for teachers with experience from 1 year to 15.4 years. It actually told you in the prompt also that the right boundary of each class isn't included in that class. So the one that ends with 16 years doesn't include 16 years. So we're just going to count how many people fell into each class up to the boundary for 16. So there were 79 people in the first class and 34 in the second, 28 in the third, 29 in the fourth, 19 in the fifth class, and then we're out of year. So this is from 1 year to less than 16, which is 189. Well, 189 teachers out of 221 teachers is a probability of 0.85, I think that's a 5.2. So there's an 85.52% chance of drawing a teacher at random from distribution B and having that teacher have an experience year within 1 standard deviation of the mean. Don't make a mistake with the word within. We did that before on the midterm and I think an exam prior to that. Within does not just mean above. Within is below or above. If I'm within 1 standard deviation of the center, I'm between -1 to +1. Please don't forget that. But again, do not use normal distribution, normal probability in this problem. It is very, very wrong. If you just think empirically right now, what is within 1 deviation of a normal curve? 68%. This is 85.52%. It's not 68%. It's not even close. The curve was anything but normal. Please remember, don't use things we can't use. It doesn't make sense statistically, and it's going to hurt you score-wise on the exam. Moving on to prompt number 6. All right, prompt 6 has a lot of parts to it. However, they're not really all that hard. 6A asks you to describe what a type 2 error was in the context. In this case, we're talking about the blood pressure of people at a certain company. Type 2 error, as described, will be erroneously failing to reject the null when we really should. If I fail to reject the null statement, what I get is that I would say the blood pressure really is 122, when in fact it is higher. That's a type 2 error. Okay, so far so good. Now, part B gave us information, okay? And it asked you to do a little bit of a roundabout operation to find the blood pressure at which we would reject the null at 5%. So in part B, I have a sample size of 100 people. And I'm told that the center of the distribution is 122. And the standard deviation is going to be 15 divided by the square root of the sample size 100. And that gets me 1.5. So far, so good? Okay. If you reject the null at the 5% level, that means that there's got to be an X value, an X bar in this case, that's higher than the bottom 95%. So, if I look at a curve, and if this is my top 5%, remember, if we are up here, where the area is less than 5%, we're going to reject the null. So the question really is, what is the X value? What is the number there that would be the boundary for rejection? Well, I know that the z-score up there, if there's 5% above, my z-score is 1.6449. You could find that either on a table, the calculator, or remembering that the 90% confidence interval had 5% above and 5% below, and the critical z-score for 90% was 1.6449. Now, little algebra on paper. Remember that z equals x bar minus mu over sigma sub x bar, which was really sigma over, I'll just put the formula radical n. So I'm looking for a z-score is 1.6449 equals some x bar I'm looking for minus 122 over 1.5. Multiply by 1.5. And now I get a value of 2.46735 equals x bar minus 122. Add 122 to both sides. You get 124.46735. Yes, I know, you could have used inverse norm and you could have just plugged in the values, but you can't really show that on paper to support your math to get a better score on the FRQ portion. What this means was if I got a sample mean that is 124.46735 or higher, I would be able to reject the null that the true mean is 122 at the 5% level. Okay? We need that number for the rest of the prompt, so hopefully you got that number. But if you didn't, you still answer the rest of the prompt using the number that you got. And if it's wrong, but at least you get credit for the subsequent parts because you'll be doing the right math. Okay, so part C question was, what if the true average of the blood pressure of people at this facility is 125? Okay, so the question was, what's the probability of us accurately rejecting the null in that instance? So all we're going to use now is normal probability rules. So here's what we would do. What is the probability of finding a sample mean that we just found or higher, so 124.46735 to an infinite bound, if the true mean is actually 125 with a deviation of 1.5. Remember, here we're using the true mean. We were just given the information that our sample really, our population, not sample, has a true mean of 125. So we're looking to find the truth, which in this case would be the alternate hypothesis, that it really is 125. It's higher. And I get 0.6387. There is a 63.87% chance of correctly rejecting the null hypothesis when the alternate hypothesis is true and the true mean here is 125. Part D, what do you call that? What do we call the probability of correctly rejecting the null when the alternate is true? We call that the power of the test. And that's the answer to part D. I just wanted the vocabulary term. It's the power of the test, the probability beta of rejecting the null when we're supposed to. So we didn't fail to reject. We avoided a type 2 error. And finally, part E. Well, there's more than one way to solve the problem, but I mean, if you want to just pick a number that's more than 100 and see what happens, that works. So what if instead of using the sample size of 100, I had a sample size of 200? It just asked what happens with a larger sample. So will the probability be higher or lower with a larger sample? Just plug in a bigger number. And if I try 200 people, I get 0.6922. Well, that's higher than it was before. It's about 5.5% higher than it was before. My probability has gone up. The power of my test has gone up with my sample size increasing. We talked about this. How do we better the power of the test? Increase your sample size, or do what to alpha? Anyone? As alpha goes up, power goes up, because beta goes down. That little plug-in statement supports us saying the probability increases. You could have said, as the sample size increases, the power is going to increase, because that's the definition of the power of the test. It goes up when alpha goes up, because beta goes down. So that would have been a good answer. So many good answers here. You could have drawn a sketch to see what's going to happen to the area, but that's not entirely necessary. These are all the possible good answers you could have come up with for 6E. All right. Well, that's question 6. We're done. What I'm going to do, obviously, you've already seen the classroom, is I will have the rubric posted for 2018 FRQs. And I understand we went through everything already, but go back over your answers and see what score matches up with your answers from the rubric. See how you be doing. All right. We're just trying to get in the habit here of answering the prompts in the way that will get us the highest possible score. That's the goal. For tonight, there is no additional homework. Take a breather. Tomorrow, of course, there will be. So have a wonderful day. I'll see you tomorrow.